Dr. Chantal Farmer is research scientist in sow lactation biology who has been working at the Sherbrooke Research and Development Center of Agriculture and Agri-Food Canada since 1986. She obtained her Bachelor of Science from McGill University, her Master's from University of Saskatchewan, and her PhD from Pennsylvania State University. Dr. Farmer's research goal has always been to improve sow milk yield and performance and nursing behavior of suckling piglets. She was a pioneer in studying mammary development and gilts, and she has published 170 scientific manuscripts, 10 book chapters, and the sole editor of 2 books that were also translated and published in Chinese. Dr. Farmer's expertise is recognized internationally as evidenced by her being a guest speaker in 13 European countries, as well as China, Australia, Mexico, Canada, and the United States. In 2022, Dr. Farmer received the American Society of Animal Science President's Award for International Achievement in Animal Science. Please help me welcome Dr. Chantal Farmer.
Thank you very much, Mark, for this introduction. Can everybody hear me well? Perfect. Well, first of all, let me tell you how happy I am and mainly honored to be here. I mean, I've heard about the Leman conference for the longest time, and I'm not even a vet, and I'm invited here, but I've been married to a vet for 32 years, so I think maybe that counts. But he's a dairy person, so no, I guess that doesn't really count. Okay, so today we will talk about mammary development of the gilt, lactation biology, and colostrum intake. I'm going to start by telling you something that you already know, so please don't leave saying I'm not going to learn anything. We're starting from scratch. Newborn piglets are most vulnerable. Why are they most vulnerable? Low birth weight, they lack energy reserves, they have low metabolic rate, they have basically no immune protection, and also we have a greater incidence of IUGR piglets, intrauterine growth restricted piglets, because now we're using hyperprolific sow lines. So we have more piglets in a litter, but the uterus is not growing as fast. So we have some crowding in the uterus, and these IUGR piglets will have lower vitality and lower ingestion of colostrum. Now, colostrum we know is essential for growth and survival of the piglets, and it's been found that each piglet needs to consume 250 grams of this colostrum. Well, in 2012, Hélène Kennel did a study, and she observed that 1/3 of the sows are not producing enough colostrum to fulfill that 250 gram need for all the piglets in her litter. So we do have a problem. And we don't only have a problem with colostrum, we also have a problem with milk intake. The sow is limiting growth rate of the piglets because she's not producing enough milk. How do we know that? If you take a baby pig, and on top of the milk it's receiving from the dam, you also provide supplementary liquid milk replacer. This piglet will grow faster, greater pre-weaning growth rate. So the growth capacity of the piglet is greater than what it's getting in terms of nutrients from the sow. And obviously, piglet weaning weight is important, so it's something we need to work to maximize. How can we work this? One way that we could try to increase milk yield is by increasing mammary development. Why are we interested in mammary development? Because we know that the number of milk synthesizing cells that are present in mammary tissue at the beginning of lactation will impact milk yield. Just makes a lot of sense. The more cells the sow has that can synthesize milk, the greater her milking potential. What do we do today? Some basic knowledge on mammary development. I will cover when does mammary development take place, what are some of the basic, most important hormones to affect this development, how can nutrition affect mammary development before puberty and also in late gestation. And we will focus on lysine intake in gilts and also in sows. Then I will talk about body condition and mammary development. Is there a link between the two? Transition feeding. Can we do anything in that special period between the end of gestation and the beginning of lactation to increase colostrum yield? Oxytocin to prolong colostrogenesis. We're moving here with 2 management strategies in early lactation. Prolonging colostrogenesis with oxytocin or teat use in first lactation. Is that important for a teat? Should all teats be used in the first lactation or not? and then conclusion. Again, I bet this is nothing new for all of you, but I'm still going to go through it really fast. Each teat has 2 lactiferous ducts. These ducts will ramify into ductules, at the end of which you have the alveoli. The epithelial cells around the alveoli are the good milk synthesizing cells. What I want you to remember from this slide are the 2 words in French. I only wish. No, the 2 words in red. Anyway, parenchyma. Parenchyma is the good milk synthesizing tissue that contains epithelial cells. Extraparenchyma is the fat layer around the mammary tissue, which has no relation to the amount of milk synthesized. So you will see these words come later on in the presentation. When do we see any mammary development taking place? Well, at birth, there's mainly stromal tissue in the mammary glands of piglets. Very poorly developed duct system. Well, they don't need it, so that's okay. Then in the life of the pig, you have 3 phases of rapid mammary development. The first one is before puberty, and it starts at 90 days of age, not before. So from 90 days of age to puberty, you have rapid mammary development. Then you go to gestation from 90 days or 85 to 90 days of gestation up to farrowing, second period of rapid mammary development. Then lactation. I'm going to tell you what I always say. 3 times 0 gives 0. If you are not in one of these 3 periods, I don't care what you're going to give the animal in terms of feed, hormones, management, it will not increase mammary developments, because if there's no development, it will not increase. But if you work in one of these periods where you do have some mammary development, you could steepen the slope through treatments. So that's obviously what I'm trying to do. And basically, I'm more interested in the first 2 periods because I want the animal to start lactating when she's already got an optimal amount of cells that can synthesize milk. So we're really focusing on these 2 periods. What are the key hormones for mammary development? Prolactin. Estrogens. IGF-1 is not a hormone, it's a growth factor. Insulin-like growth factor 1, which is the mediator of action of somatotropin. Some people call it growth hormone, but it's really somatotropin. Those are 3 hormones that are important. And they're also important in terms of treatments. So that's why I need to give you some basic background so you can understand the treatments to stimulate mammary development later on. Estrogens, before puberty, they don't do much. At puberty, yes. At puberty, you have a significant increase in the mass of the parenchymal tissue. In my presentation, whenever you see a number in red, it means it's significantly different. So more parenchymal tissue in pubertal gilts compared to non-pubertal gilts, but also more estrogens that are being present. And it was said that this greater development was linked to the presence of circulating estrogens. How about gestation? Is there a role for estrogens in a gestation? We know that estrogens are produced by the fetal-placental unit. And we also know that at the end of gestation, day 110, there is a positive correlation between the estrogens in the blood of the sow and the DNA in her mammary tissue. Why are we interested in DNA mammary tissue? DNA gives you an indication of the number of cells. So yes, you're interested in DNA. Well, I am anyway. So more DNA when more estrogens. And the authors said, well, maybe this positive effect of estrogens to stimulate mammary development could be linked with prolactin. What do we know about prolactin? In 1945, I wasn't even born, feeding barley ergot was shown in the last 25 to 87 days of pregnancy, was shown to either lead to, well, either, or it could be both also, no other development at all, and agalactia, no milk production. Then, in the 1970s, the radioimmunoassay to measure porcine prolactin in blood was developed. And then when they saw that problem, they took blood from the sow and looked at porcine prolactin, and they saw, oops, that's the way it worked. The more you had of this barley ergot, the less prolactin you have. So that could be the reason why you had the agalactia. So then I came along, then I was born, and educated. It took a while. Anyway, so then I decided, let me see whether prolactin does, in fact, by itself, have an effect on mammary development. So in the last third of gestation, in this case, from days 70 to 110 of gestation, I inhibited prolactin. You need to know how prolactin is controlled. The secretion of or synthesis of prolactin is under negative control through dopamine. More dopamine there is, less prolactin, and vice versa. So if I want to inhibit prolactin, I give a dopamine agonist, which in this case was, whoops, what am I doing? In this case was bromocriptin. So I gave this prolactin inhibitor from the 70 to 110 of gestation, slaughtered the animals, cut the glands, and this is what I saw. C is my control animal, so a nice pink parenchymal tissue, and the extra fat layer, extra parenchyma. Now we're moving to the other side. Things are not looking good. Look at this parenchymal tissue, which is interspersed with a lot of fat, very poor development, and a lot more of the extra parenchymal tissue. Major, major inhibition if there is no prolactin. I told you before that the mammary development in late gestation starts at about day 90 of gestation. This is day 70. So I did another study, trying to pinpoint the specific period where prolactin has an effect. So I've treated with bromocriptin from days 50 to 69, 70 to 89, or 90 to 110 of gestation. And when I told you that 3 times 0 equals 0, you have it here. In periods where you don't have any mammary development, even if you get rid of prolactin, it didn't change anything. Same amount of parenchymal tissue. But watch out when you give it when there is mammary development taking place. Then you do get a significant decrease in mammary tissue. So prolactin is needed from days 90 to farrowing for mammary development. If it's needed, how about giving it? Can we improve things? The one study where I've actually given injections of porcine or recombinant porcine prolactin is in growing gilts in that critical pre-pubertal period. So for 29 days, it was given starting at 75 kilograms. And what did I see? Whether you give 4 or 8 milligrams of porcine prolactin doesn't make a difference. You already have maximal effect at 4 milligrams, and you have a doubling of parenchymal tissue. That's just not just a little bit. You're doubling it. Amazing. Less fat, which makes sense, a lot more protein, a lot more DNA, so a lot more cells. And when you look at the animal, you can see that the underline, instead of being straight, you can already see some mammary development. I could stop here, but I have to continue to be honest as a scientist. When we slaughtered these gilts at puberty, look what we saw. Some lacteal secretions. Wow. She's producing milk and she's at puberty. What's that going to do when she will be lactating? I have no idea. And I'm really sorry to say that I love to read murder mysteries, and if somebody would do what I'm doing to you today, I would not be happy, because I'm going to do just like telling you a murder story, not telling you who the murderer is. I do not know. Is it good or is it bad to have more mammary tissue when you start to give milk at puberty? Will that increase milk yield and lactation or not? I don't know. And I cannot redo that study. There's no more recombinant porcine prolactin hanging around. So we had to find other ways to look at this. The other way that we found to increase prolactin was a dopamine antagonist. If you can inhibit prolactin with a dopamine agonist, why not use a dopamine antagonist, which is what was done here with Russ Hovey. So a dopamine antagonist, like domperidone, this is what was used here, was given from days 90 to 110 of gestation. Just so you know, when we measured the prolactin in the blood, it's only between days 90 to 97 that there was a significant increase in prolactin. Because I later did another study and results were different. I'll tell you in a second. Okay, you give it in those days, the prolactin increases from days 90 to 97, you increase alveolar volume, increase milk yield by 25%, increase the weight of the piglets without changing the composition. This is great. what I wanted to tell you is I've done this study also later on, and I managed to increase prolactin for a longer period of time. Then it got to be bad. If you have too much prolactin in late gestation, the sow will start producing milk with no piglets to remove it. So you start to get an involution. So don't ever do that. But some veterinarians phoned me, and they're actually writing prescriptions to use domperidone, and they said when? Day 90 to 97 of gestation. How to do commercially? Instead of having to ask your favorite vet for a prescription, could there be something that they could do through feeding to increase it? I was very hopeful in 2014, yet I'm still standing here, so you can see what happened with my hope. But anyway, I decided to use silymarin as a prolactinemic agent. Silymarin is an extract of this weed, milk thistle. Silymarin was shown to increase prolactin in rats and also to increase milk yield in cows and in humans. So then I said, wonderful, I'm going to give silymarin to sows and I'm going to retire early. But in fact, I'm much happier working. So I fed this. Yes, I did increase prolactin, but not enough to see any improvement in milk yield. You need quite a bit of an increase in prolactin to see that improvement. IGF-1, insulin-like growth factor 1. What we've done here is increase concentrations of this growth factor by giving injections of porcine somatotropin in that critical period from days 90 to 110 of gestation. Then when we slaughtered the animals, everything in red is significant. So significantly more parenchymal tissue, less fat, more protein, more cells, more RNA. What does RNA stand for? Metabolic activity. Wow, things are looking good. More mammary cells that are more active metabolically. So this is really interesting results. We know that we have positive effects of IGF-1 on both the amount and the composition of the tissue. Now what needs to be done is to work on nutrition. I've read things that maybe betaine could stimulate IGF-1, so nutritional companies need to work to increase it. And sadly enough, a nutritional company in Europe was doing it, but then after a couple of years when they were really trying to find good things, and they had some interesting results that they did not want to share with me yet, then they changed direction. It's as bad as the murder thing I did to you. Anyway, nutrition. What do we know about nutrition and mammary development? Nutrition in both of these critical phases. In pre-puberty, 20% feed restriction will inhibit mammary development. Look at this. From days 90 to 202, 20% feed restriction, less parenchymal tissue. If you do that same feed restriction before period 1, day 90 of pregnancy, of age here, before puberty. So period 1, before day 90 of age, you would do a 26% feed restriction, you don't have an effect. 3 times 0 equals 0. Doesn't matter what you do before 90 days of age. But don't do it, please, as of 90 days of age. As of 90 days of age, you do that restriction, and feed restriction has a negative impact on DNA and on RNA content. So you want these animals to eat as much as they want. Yeah, then you give this talk to producers who look at you and you say, well, I'm very sorry, Dr. Farmer, but I've got gilts that are growing too fast, that have leg problems, that will not have a long longevity in my herd, and I want to restrict their feed intake. Oops, I'm in trouble. I told them not to do it. What do? I do another project. Can we decrease feed intake of these gilts without causing a negative impact on mammary development? So I've done a study with Leon Huber at University of Guelph, where we either fed a controlled diet, the same 20% feed restriction I'd fed before, and a 10%, maybe 10% feed restriction is okay and would slow down growth rate of these gilts, or a high fiber diet, increasing fiber by 25%, thereby diluting energy by 5%, maybe that will solve the problem. In that case, we did not slaughter the animals. We actually let them farrow. Can you hear me well? Yeah? Okay. Nobody's dozing off yet. Good. And then we looked at growth rate of the piglets in the next lactation. Then what happens? No effect. Boy, I must have done something wrong. If I say that a 20% feed restriction decreases mammary development, there is no reason why she would give the same amount of milk. So I went back and I looked at the original data. And when I looked at the feed intake, that's where I saw a difference. The first study where I saw an effect of feed restriction was done in 2004. Control animals ate 2.88 kilos per day. Fine. In 2022, that control animal is going to eat 3.5 kilos. So if you do a 20% feed restriction, boy, you don't come up to the same number. 2.11 kilos per day was negative in terms of mammary development. 2.7 kilos per day led to the same amount of milk yield. So there may be a threshold in the amount of feed that's being given to these animals before puberty to ensure maximal feed intake. I'm right on time, half an hour. No, 20 minutes, sorry. I have to time myself. I have so many things to tell you, so we got to jog along here. Prepubertal nutrition after feed restriction, protein intake. Does protein intake before puberty affect mammary development? If you feed 14.4 or 18.7% crude protein at that crucial period before puberty, no effect on mammary development. Fine. Let's move on. What else could affect mammary development before puberty? I told you estrogens are important. How can I increase estrogens in the blood of the animal? Well, maybe we can feed a source of estrogen, a plant source of estrogen, phytoestrogen, which is what I did. So when I gave either a standard soya diet or that same diet plus 2.3 grams per day of the plant estrogen genistein, then I slaughtered the animals at puberty, and then I looked at mammary tissue. The phytoestrogens in blood increased, which is good. If it didn't, I'd be in trouble. And there was a 44% increase in parenchymal DNA. Large increase in the number of cells on this nice mammary tissue. I think any way that you would increase estrogens would have led to the same results. Estrogens have a positive effect in terms of mammary development in that critical prepubertal period. That's all we know on positive effects in prepuberty. Gestation. How about energy? If you gave a large amount of energy, 10.5 megacal of ME per day, compared to around 6, it either has a negative effect, decreases mammary parenchyma, no effect, or increases parenchymal fat, which we don't really care. So, and also if you increase polyunsaturated fatty acids, there's no effect. What I'm telling you here, energy is not the way in gestation to stimulate mammary development. Okay, what else could be the way? Let's look at protein. If you give 330 instead of 216 grams of crude protein per day at the end of gestation, no effect. If you give 4, 8, or 16 grams of lysine per day throughout gestation, no effect on mammary development. But when you get into lactation, you will have an increase in terms of milk yield in the 16 grams per day. So maybe something's going on. So what do I do when I think something may be going on? I do another project. So in this case, what I've done is I've increased lysine intake by 40% in late pregnant gilts. How did I achieve this? By increasing the amount of soybean meal. Anybody in the audience will tell me, oh yeah, Chantal, you did not just increase lysine, you increased other things in the soybean. Yes, I give it to you. I did increase other things. But you have to start somewhere. So in this case, the estimated requirement for our gilts was 18.6 grams per day of SID lysine. By increasing soybean meal in the diet, I moved up to 26 grams per day, 40% increase. The diets were isoenergetic, all amino acid met requirements from the NRC. And obviously, the crude protein was greater, and other amino acids were also greater. But lysine is the one that was increased by 40%. Now let's look at mammary tissue. One variable was very significantly affected, parenchymal tissue. Significant increase. And when you look at it, it's a 44% increase. Well, that's funny. I increased lysine intake by 40%. I increased Mammary parenchyma by 44, that's a 1-to-1 ratio. That's really interesting. Composition, no change. It's only the total amounts that vary, but not really the percentage. So it's the amount of this parenchymal tissue that's different. So then I say, fine, I'm going to go and stand in front of producers and tell them, oh, you need to do phase feeding in gestation, and I get thrown eggs and rocks and whatever, but that's the way to go. You have no choice. But do they need to do this on all the animals? Do they need to do it also on sows or only on their gilts? So I've done another study, same 40% increase in lysine, again by increasing soybean meal on multipairs animals. So the estimated requirement of the late pregnant sows was 14.8 grams per day of lysine, moved up to 20.8. Obviously, I increased protein from 14 to 18%, increased other amino acids, but same thing as in the first study. Then I look at the mammary tissue. You know, quite a few times in my life, but don't tell my husband, in terms of science, only science, I've been wrong. So you start this trial and you say, wow, why would the multipairs animal be different? Oops, it is different. So the multipairs animal, no effect whatsoever. So it's important to do this phase feeding only in gilts. Nutritional requirements for mammary development differ between the first pregnancy and subsequent pregnancies. It's likely because the gilts are still growing, they have greater needs, but it could also be because they could have less parenchymal tissue to start with when you mate them. And that's kind of interesting because when you look at the end of gestation, at the amount of parenchymal tissue that's present, the gilts, control animals, 1437 grams. You give them lysine, moves up to 2071. Red numbers are significant. When you look at the sow, she's already starting with the same amount of parenchymal tissue that was present in my animals that got the lysine when they were gilts. So I presume this animal had more parenchymal tissue when she was bred. So maybe when you have more, there's a certain threshold. It's difficult to go above. And then when you get to the end of gestation, well, there's no effect of increasing lysine. So you really need to treat the gilts and the multipairs animals differently. So now I don't get so many rocks. It's only the replacement gilts they need to do phase feeding with. Body condition. Is there an effect of body condition on mammary development? Very early on in 1991, it was shown that a 36 millimeter of back fat in a sow compared to 25 millimeter will decrease the amount of DNA, decrease the amount of alveolar cells at the end of gestation. So being obese in this case has a negative impact and also negatively impacts the next lactation. How about if we are comparing body conditions that you see commercially? I don't really care about 30-some millimeters. If somebody has that in their herd, they have a problem. But normally we have lower back fats. Will there still be changes in mammary composition? So what I've done is a study where I started at mating with everybody with the same back fat, 16.4 around millimeters. Then I fed the same feed, but different amounts, to achieve 3 groups at the end of gestation. 22, which is high back fat, 18, standard, 14 millimeters, which is a lean animal. And then again, I was wrong. Can you believe it? Twice in my presentation, I'm telling you I was wrong. That's why I keep doing science. It keeps me on my toes. You look at this and you say, okay, well, the fat animals will have poor mammary development. No way. The other way around. Can you believe? In this case, being thin was bad. There you go. So, less parenchymal tissue when the animal is thin. Okay. You can go up all the way up to 26, not 36, but all the way up to 26, and things are fine. So there is quite a bit of range where you could have the back fat of the animal without any problems in terms of mammary development. Now let's achieve the same 3 groups of back fat at the end of gestation, but for a different reason. Because you already are fatter to begin with. Some people, it's hopeless. You will be fat. So these gilts started with more back fat at mating. We fed them different amounts of the same feed to maintain differences. Then we looked at results at the end of gestation. 3rd time I was wrong. 3rd time. Look at the results. No effect in these lean animals. Whoa, that's weird. It's not weird, it's really interesting, it's science. The reason for the difference in back fat thickness at the end of gestation is important. If it's because you're feeding more your animal, then you see an effect. If it's because the animal was already fatter to start with, it doesn't make as much of a difference. Anyway, it doesn't make any in terms of the amount of parenchyma, which is what's most important. So what I can tell producers now, feed intake, hi Mark, nice to see you. I'm mean. Feed intake in gestation is more, he's heard me a lot of times. Feed intake in gestation is more important than back fat at mating in terms of the amount of mammary parenchymal tissue present. There's a negative impact of a gilt that's too thin, less than 16 millimeters in the gestation, but no negative impact going all the way up to 26 millimeters. So you have a gap. Now somebody will ask me, yes, you use Yorkshire Landrace. How about another breed? I cannot tell you in another breed the number of millimeters that's okay or not okay, but I can tell you the principle. Being too thin is not good, being obese is not good, and being somewhere in quite a big range in the middle is fine. So basically, producers need to look at body condition and not have animals that are really too thin. Transition period, that generally consists of the last week of gestation, first few days of lactation, from day 108 of gestation to 305 of lactation. An adequate supply of nutrients is needed for colostrum yield. Okay, so if we feed different amounts to the animal, will that affect colostrum yield? And those are studies done in Denmark. They're really ahead in that area. So when they fed 1.5 compared to 4.5 kilos per day, starting on day 108 of gestation, tendency to decrease colostrum yield. When they fed 1.5, 3, or 4.5 kilograms, starting on day 104 of gestation, tendency to increase colostrum as feed intake was increasing. And the last study done by Tekele Ferreira, feeding different amounts of feed going from 1.8 to 5 kilos per day, starting on day 108, maximum colostrum yield at 3 kilograms per day. So we may be underfeeding in some cases when you look at colostrum yield. We could assist them by feeding a bit more in that critical period. Dietary lysine, if you feed a lactation diet, which contains more protein, instead of a gestation diet from day 104, it increased colostrum intake by the piglets. Feed intake in 2023 was also shown to potentially also affect lactation milk yield. So when they fed 3.7 kilos per day, they had a greater milk yield in the first week of lactation, which is the week that is critical in terms of piglet growth. Just to cover very fast, some management procedures to assist you. Farrowing induction is something that's done, and it's good. We need to do it. You need to be present for farrowings. But does it affect colostrum yield? So when you give prostaglandins to induce a farrowing, the timing of this induction is important. If you do this on day 114, but look at the date, it's about 2018, it's not so old, but I'll tell you what I want to say about that later. No effect on colostrum yield. Okay, you do it on day 111, tendency to decrease colostrum yield, 113 also. This negative was greater when you induce it on day 109 of gestation. 32% less colostrum yield, 10% less piglet birth weight. The timing is important. Now what I want to add is, those numbers are with the animals of those years. But nowadays, hyperprolific animals have longer gestations. So you have to be careful, because it may not be 109 now, it may be 110 or 111 where you see major problems because the gestation is longer. But be careful about timing of induction. Colostrum production, boy, it lasts only 24 hours. Can we do something to make that period longer? The colostrum composition is affected by the status of the tight junctions between mammary cells. The looser they are, which happens when colostrum is produced, the more of the larger molecules in the blood, can pass and go into the lumen and into the colostrum. So as time goes on after farrowing, there's a decrease in colostral proteins, colostrum immunoglobulins. Now, could I give a very high dose of oxytocin and impact the duration of colostrum production? What I've done is I've injected a very high dose of oxytocin, supraphysiological, 75 international units. You would never use that normally. But one injection intramuscularly was given 12 to 20 hours after birth of the last piglet, averaging 16 hours, which on this slide is going to be day 2 a.m., the injection. 8 hours after the injection, you see here on the slide, day of lactation, immunoglobulin G in the blood, in the milk. If you look day 2 a.m., day 2 p.m., oops, significant difference. Much more IgG in the milk of the animal that received that high oxytocin dose. I've also looked at IgA, it was greater, IGF-1 was greater, and I looked at the sodium-potassium ratio. As a lactation biologist, to me that's a tool that tells me how tight the mammary junctions are. Significant effect. The junctions were looser 8 hours after the injection. So yes, I can affect the quality of early milk by giving one IM injection of a very high dose of oxytocin. Management in early lactation, the last thing I want to talk about, suckling of a teat. Is that important? We know that in lactation, if a teat is not used, it will undergo involution. If after 48 hours that teat is being used, it will produce milk, but never, never as much as the next one that was used as the beginning, starting at the beginning of lactation. And if that teat is not used for 72 hours, then it involutes and it's irreversible, nothing you can do about it anymore. So what should be done? When you have a primiparous sow that is too thin and that has a very large litter size, should the producer fill all the glands, or should they give her a break and say, oof, I'm going to give her a break in parity 1 to make sure that she stays on in parity 2. So what I've done is I looked at the impact of teat use in first parity on production of milk by that teat in second parity. First parity, there we go. First parity, I'm blocking, no, you can't see this yet. I'm blocking 8 teats. So if there's 14 teats, I block always the hind ones. Then I block 6 teats, and be careful about the side, left, right, left, right. I leave 6 good piglets of average weight to suckle 6 teats. Life is great. Move on to lactation 2. I block the same teats. So those 6 piglets drink from a teat that was used before. This may seem foolish, but it took me a while to come up with that. I know, you may tell me it's my problem, but anyway, I managed, so that's what matters. The second treatment here, we block the opposite teats. So those piglets, if you compare their growth rate to these piglets, they're suckling teat that were not used compared to teat that were used. And now what happened? In parity 2, you look at growth rate of these piglets. There were differences starting somewhere in lactation, but when you reached 50 days of age, then it got significant, 1.12 kilogram more. So yes, there is an effect of a teat that was used in first lactation. Furthermore, I slaughtered the animals and I looked at the mammary tissue. I increased, not me, but the teat being suckled in first lactation, increased the parenchymal mass in the second lactation, at the end of lactation, increased the DNA, number of cells, increased the RNA. So yes, it's important. If you look at the weight gain of the piglets, I did not look at colostrum yield, colostrum intake, too old to spend nights in the pig barn. But if you looked at the growth rate from days 2 to 4, already significant. Leads me to think that yes, there might be a significant effect of this teat use on colostrum yield. Next question, does the mammary gland need to be used or suckled for the whole lactation, or just a small period of lactation? So parity 1, I had 3 lactation lengths, 2, 7, 21 days. Parity 2, I looked at growth rate of the piglets. No difference. Even though there's no significant effect, those are wonderful results. because now I can tell a producer, it doesn't matter how long, as long as you have 2 days in first lactation. So what you need to do, you need to get the teat suckled for 2 days in lactation 1. And then if you want to give a rest to these poor little primiparous animals that are thin and that have too many piglets, do it on day 3. You'll be fine. And conclusions. Do not despair, Mark. I will finish someday. Conclusions. Gilts should be fed to maximize their mammary development before lactation starts. Okay, if I summarize what we said today. Pre-purity, from 90 days of age to puberty, you don't want to have a feeding take below 2.7. The cutoff is somewhere between 2.11 and 2.7, and I have no idea where it is. So maybe a little bit below 2.7 is okay, but I don't know. I just know 2.7 is okay. If you can increase the amount of estrogens through phytoestrogens in the diet, that will be beneficial. If you can increase prolactin, that will be beneficial for the mammary tissue. I don't know what will happen in the next lactation. Gestation, from day 90 of gestation to farrowing, no overfeeding energy, has a negative impact. Obviously, no decrease in prolactin, and in fact, if you can increase prolactin, but not too late in gestation, you will increase milk yield. Increasing IGF-1 will have positive effects. Feeding 40% more SID lysine by putting more soybean meal in the diet. Please, that's important. We're checking now if giving the lysine directly will have the same effect, but for now, it's soybean meal. Will have a beneficial impact on mammary development, so phase feeding will be beneficial to increase this lysine with soybean meal in gilts, but not in multipair sows. Throughout gestation, you need to feed to achieve optimal body condition, more than 16 millimeters, going up to 26. Transition feeding, if you feed 3 kilograms per day, starting on day 108, you will maximize colostrum yield. Do not induce farrowings too early. If you give 1 injection of 75 international units of oxytocin, around 12, 16 hours after birth of the last piglet, you will prolong the colostral phase. And you need to make sure all the teats are suckled for the first lactation for 2 days. Then I thank you, and I also want to say, sorry, those are the 2 books I've edited. So if anybody wants more information on the sow or on the piglets, these are something that are available. And I'm going back to this. Thank you.
Thank you, Dr. Farmer. Thank you so much. Time for questions. We have 2 assistants carrying microphones around.
Fantastic presentation. Thank you, and thank you for your passion. Question on increasing amino acids in late gestation. I believe you talked about increasing estrogens or phytoestrogens potentially increases mammary tissue. So you're increasing soybean meal, which would potentially have more phytoestrogens. So how do you separate out the increased amino acids versus increased
Excellent questions. I've done a study, which I did not mention here because I've got too many studies, where I actually compared corn-soybean diet with a diet that had no soybeans, so it did not have the phytoestrogen source. And when I looked at mammary tissue, there were no differences. So the amount of phytoestrogens present in the soybean is not large enough with current amounts that we put in the feed to change mammary development. But good question.
Thank you. Very good presentation. Wondering if you have any suggestions, recommendations in terms of the piglet size for those first 2 days to get enough intensity of suckling to make sure there's no, negative effects on subsequent lactation.
Oh, not on that lactation, but on the lactation afterwards?
Yeah.
I have no idea, because that project hasn't been done. What I know is I use piglets of an average body weight, and the massaging and the suckling was enough to lead to good milk yield from that teat. If it had been a little runt piglet that massaged a gland, would we have seen less of a good effect for the next lactation? I don't know, but. If you look at molecular biology, the increase in the mRNA for important, genes for lactation, the study wasn't done to compare size, but you see it on a general basis. My gut feeling, but I've been wrong twice, no, 3 times today, but my gut feeling would be that if the gland is suckled, then it's active and it would be okay. But please don't quote me on this. If you don't quote me, I don't know who you're going to quote. But that needs to be done. That's interesting. Is there a cutoff point in weight in the first lactation? I doubt it, but it needs to be done. I saw a hand here somewhere. There, yep.
I guess I'm close. Oh, thank you. For the big dose of oxytocin, we actually try to implement with some of our clients this, because I'm a big fan of you and your work. And not all of them are willing to inject every sow after pairing. Do you know, is there a bigger effect in gilts and P1s compared with the sows? Because those are usually the ones that they have issues with in terms of colostrum intake.
2 things. All my studies mainly are done with gilts. So what I can tell you is gilts. But the colostral phase is the same between a gilt and a sow. It's 24 hours. It doesn't matter if you're a multiparous animal. Colostrum will not be produced for a longer period of time. Colostrum intake between primiparous and a multiparous, I'm not sure that it's that significant. Do you have data on this from your herd? But my gut feeling is that the same effect could be seen in both animals, because you prolong the colostral phase, so that's beneficial no matter what for the piglets. But if the piglets are bigger in a multiparous sow and they suckle and massage more, maybe they'll make up for it in terms of milk production. But the amount of colostrum produced is not linked with litter size. So you may have a better impact in multiparous animals for milk yield if the piglet is bigger, but not colostrum yield. So if you look at survival, then colostrum is the key. So to me, it would be the same in gilts and multiparous.
I guess the only practical observation that I can tell you about is that, and again, it's not my farm, so I'm not there every day, but we work with multiple clients, and then it's a general observation. And we are trying to change that by teaching them. If it's a habit, I think it's an old habit. If you have a gilt, you're going to put the small pigs on her. And usually those are the gilts that they have issues with. So, or even if you don't want to move, so you leave them with her original pigs, but they're very small. Or they have a scour challenge that starts day 1, day 2. That's where they see those, she just stops milking because or the piglets just don't have enough colostrum, and you lose them in the first week.
Yeah. And then that leads to the previous question on the amount of massaging and the impact for that milk production from that one teat in the next lactation. But sadly enough, it's not something that's ever been looked at. Relevant questions, though.
Similar along those lines of the follow-up, the question on where pigs seem to be healthy and the sows seem to be doing well, and then we have a mid-lactation where a lot of sows go through an agalactia, more of a herd-wide basis. When herds seem to be doing well and then they have like a 7-day of age where the sows dry up, thoughts on the pathogenesis of that or the hormone imbalance? Do you see that or have any?
Okay, pathogenesis to me, you would need to have an inflammation. The other would need to be red and you need to be inflamed. And most of the times that's not the case. She's just not producing milk, because I've got that question before. And I always come back and say, well, it's in my mind, it's a matter of massaging and getting rid of the milk that's in the gland. What happened? Did you have a noise? Did you have too much heat? Did something disturb the piglets, or is a sow laying more in her underline so that the piglets do not have access to the glands? Because if the piglets suckle and massage the glands and empty the glands, she should give milk unless there's inflammation. From a hormonal point of view, I don't know. I've never measured any hormones in these cases, but
Thank you.
that's all I could say. Yeah.
I have a question, Dr. Farmer. So from a population level, from 90 days of age and older, we vaccinate, we move them, we move pigs from one grower barn to a finisher, space availability may be limited, they may be exposed to PRRS virus or to vaccines that take them off feed, and events, hot weather, right? I mean, heat that would reduce intake. So that energy limitation, and even intermittently, is there any evidence of that and detrimental effect on mammary genesis?
Easy. That's never been looked at. Do you like it when they say that? But then feed restriction, a 20% feed restriction has an impact. So we still have to be kind of logical that if for 2 or 3 days the animal is decreasing by 10% her feed intake, hopefully it will not have a negative impact. We're not talking drastic 20% over, a long period of time. But anything you can do not to decrease feed intake is best.
Thank you again. Thank you again, Dr. Farmer.